Morning. Welcome to the Minoxidant webinar series. My name is Ian Frink. I'm a Vice President at Minoxidant. Today's presentation will focus on Minoxidant fiberglass products. Our presenter is Terry Cahill. Terry has been with Minoxidant since 2008 and currently serves as our Senior Product Manager. A bit of housekeeping today for our webinar. In the lower left corner of your screen, we're encouraging participants to text questions to us. We will read back the questions and answers throughout the presentation in an effort to encourage dialogue throughout. We've also got with us today our engineers, Brian Phipps and Sam Stelzner, who've been helping us. And we've got a nice presentation today that's going to focus on the basics of FRP and some case study highlights, so kind of walking through some jobs from design to completion and installation, and some of the roles our reps have played in those jobs. Our fiberglass products are really broken into two brands, our Underduct brand and our corrosion composites. The Underduct is really more of a plan and spec type product that you're going to see in HVAC applications, where the corrosion composites is much more custom in nature. You see this in a lot of industrial settings. And without further ado, we'll go ahead and dive into our presentation, and I'll turn it over to Terry. Thanks.
Welcome, everyone. First, we're going to cover the FRP basics overview. And what is fiberglass reinforced plastic? Number one, it's a composite. And if you think of composites, the definition would be taking two different materials. When you combine them, you end up with properties that are far greater than either of the beginning properties. With our fiberglass reinforced plastic, the thermoset resin is the primary component, and it's reinforced with fiberglass fibers, and glass is the primary reinforcement. The resins can be any one of a number of thermoset resins, from epoxy to polyester to vinyl ester, some modified acrylics, some phenolics, but they're all reinforced with plastic. And the thermoset versus thermoplastic is a key thing. The thermoplastics are those that can be heated up and reused or melted, essentially. Thermoset plastics, the epoxy, the polyester, the vinyl esters, once they're cured with heat, they are not, you can't melt them. And that's why they're such a strong item to use in our industry. Fiberglass is a structural material versus the thermoplastics. It allows us to build large, lightweight, corrosion-resistant structures, such as stacks, tanks, covers, etc. Manufacturing methods include, the ones that we use are filament winding, like in the upper photo on the right, and hand layup, like the lower photo. Now, in addition, there are many different types of methods for processing fiberglass. In the marine industry, boats are typically made these days with a closed mold process, vacuum-assisted molds. Press molding is another one. Resin transfer is another one. But the industry that we're in, and our primary products, are filament wound and hand laid up. A laminate design can get pretty involved. If you look at the photo on the top, you'll see the winding around the mandrel, and those are continuous strands, and they're wound around. And the primary advantage of filament winding is for pressure or vacuum, hence duct or pipe. To allow for hanger spacing, or in the case of what you're looking in the upper photo, that's a light pole. The winding is stretched out, so to speak, and resembles a Chinese finger trap, but the angle gets longer And that gives you some axial strength so that you would require fewer hangers. So it's a combination. Filament winding alone can be hoop winding, which would be 90 degrees, or it can be what you're looking at in that light pole, which is probably about 50 degrees. So we can do a lot with just filament winding. Also, if you're building a large flat structure, like the structure in the bottom, or a large cover, you'd use woven material, 90-degree woven. This would allow you to build a big flat structure. Also, there's a lot of chop strand mat, essentially, that would fill in between the structural layers, be it filament winding or woven material. So there's a lot involved in laminate design. It's all driven by ASTM standards for our industry. Core materials. This is something that is kind of a unique thing, but core materials are meant to allow you to put a fiberglass laminate on top and bottom of, say, a foam core or a end-grain balsa wood core or a Nomex honeycomb core to get a lightweight, stiff structure. And the theory is to put a laminate on the top and the bottom that are equal. And those are structural laminates. And the core will stiffen it. And if you think of an I-beam where you have a flange and a web, the fiberglass skins would be the flanges, top and bottom. The core material creates what would be a web in an I-beam, in other words, the vertical element. And the difference is that it would run in all directions. So we can build a very large structure, say to span a 24-foot wastewater tank, and we can make it lightweight. Whereas to build that out of solid fiberglass would require a very, very thick laminate.
You have a question. With laminate design, do you provide the engineering required for this project?
We often primarily build to the ASTM standards, and there are formulas that we follow, but anything unusual, we then would do the laminate design. So the real custom things very often involve laminate design, calculations, and so on, but the typical duct system is built for ASTM and SMACNA standards. Continuing on with the basics, Minoxidant markets two main products, brands. Underduct, which is our underground heating and ventilating duct, and heating, ventilating, and air conditioning. And what you're looking at is the upper right photo is a library here in the Quad Cities, and that is a displacement ventilation system for heating and ventilating. The one in the center near the top is a vehicle exhaust system, again a buried duct system. And those are both part of our underduct product line. And the underduct is been tested and approved by ICCES and shown to meet all the building codes. So it's a building code approved product, does not require concrete encasement. It's been our biggest push, and it's been our most successful line in the last 5 years. So we'll get more into those later in the presentation. Now, corrosion composites, as Ian mentioned earlier, a lot of custom things. And the picture on the right-hand side in the middle is a typical duct system in that happens to be an acid plant where they're manufacturing sulfuric acid. Corrosion is the name of the game. The picture on the lower left is a typical wastewater plant. And what you're looking at there is a large hood. I think those hoods were 14 by 8, And they're covering a gravity belt filter press that separates the solids in the solid building. And this is a real typical wastewater application, taking those not only smelly but very corrosive fumes off of the processes all throughout the wastewater plants. Those large hoods are in fiberglass, are structurally designed so that they don't require ribs. Again, they're lightweight, do a great job, and they won't corrode. On the lower right is a typical fiberglass tank, a filament wound tank. Like duct and pipe, tanks are built for pressure or vacuum. And that's a typical tank. Scrubbers, we don't have any scrubbers pictured here, but scrubbers are essentially like a tank. There's layers of packing in them. They're meant to clean air. For instance, you could take an ammonia or sulfur-laden air from a wastewater plant and run it through into a scrubbing tower, and you'd have a bed of packing material that is wetted out with, say, ammonia, and it would take all of the sulfur fumes out of that as the air moves through it, and the bottom of the scrubber you'd collect in the sump, say, ammonium sulfate, and when the pH gets to a certain point, then that goes off to the wastewater. And they run continuously, and scrubbers can typically do 98, 99% removal of the element they're trying to remove. So they're rather common in industry and in wastewater. We've built a lot of scrubbers on an OEM basis, and we've replaced a lot of them. Custom items, almost endless when we get to custom items. They can be the item you saw in the very first slide, which we'll cover again, a large plenum for a fluid bed system. They can be trays to go under plating lines or under specific tanks. They can be, we're currently building some platforms for John Deere that'll temporarily go into the hopper or for their production line for combines. And they want to be able to get them in and out and have a man stand on them to keep them lightweight and stiff. Well, those are examples of custom things. Stacks, I kind of skipped over that, but we've done a lot of stacks. And stacks have a unique problem. It's not just a duct standing on end. If you can imagine a large stack exposed to wind and seismic and extending up in the air without any guys or any supports, and now you put the wind load against it, not only do you have to use filament winding for the stack structure, you have to put in glass in the vertical direction to help fight that whip motion or the pressure that you get from the wind load. So stacks are typically custom designed, and they're not just a tank. Now we're getting into some of the case studies. And what we try to do is highlight some of the jobs that we've completed in the last year or so, just to, with the idea that pictures tell a great story. This is the CHK Boathouse in Oklahoma City, Oklahoma. Our rep, R.B. Akins, has been very active there. In this particular project, there's 230 foot of 16-inch diameter underduct under the floor. The picture on the lower photograph shows the waterfront and the corner of the building. This is one of 3 boathouses being built along the North Canadian River, now called the Oklahoma River. And it's becoming sort of a mecca for U.S. rowing and also for kayaking, and it's a water sport center. The city has invested millions in it. This boathouse, the CHK boathouse, also called the Devon boathouse, is the second large structure. It houses the University of Oklahoma State and several other U.S. rowing venues. And what you're looking at is the underduct in that pointed building that you see on the right. The photo on the left on the top is the ductwork that's under the floor. And if you look at the base there, you'll see the register openings in the building. And it's a good example of underduct. And at the far right, you'll look at a photo there that shows the cement finishers finishing off the cement around the register boots that penetrate up through. The next case study we're looking at is AELP Fitness Center. And this is a recent project. The building isn't completed yet. Again, Oklahoma City, R.B. Akins. They're kind enough to send us lots of photos, so we feature them. This job has roughly 200 feet of 32-inch diameter duct. And the unusual aspect of this project is if you look at these duct runs, they run outside of the building. The HVAC units are all sitting on pads away from the building. So we've had to run from outdoors on into the building. And for that reason, since it's not under a slab, these ducts were concrete encased. And it's not required, but in this case it is, because we don't have a slab over it. It's underground and it could drive a truck over it or whatever. So if you look at the photos here, you'll see the guys putting the duct in and they penetrate the wall. The concrete is being poured on the top photo there, and they did encase all of these exterior ducts completely in concrete. There's a hold down method, and we gave them some instructions, and you can see some stainless bands around those ducts. If you look at the photo on the lower left where the man in the yellow shirt is, right below him is a stainless band. That's the only time when it would float out is when you're trying to encase it in concrete. When you're putting it down in dirt, you don't have to have any hold downs. So that's the next one is GEA Process Engineering. They used to be called Nairo. They're a company a European company that has been in the fluid drying, powder drying business for many years. What we're looking at here on the upper right is a large fiberglass balsa cord plenum that was designed for about 200 degrees, and it's used for drying CPVC powder. And PVC powder is not a problem. You can use their standard metal unit. But when they start to dry CPVC powder, then they have hydrochloric acid condensate because of the chlorinated polyvinyl chloride. So instead of using titanium like they used to use, we designed this system for them. And there's internal baffles, there's heaters in there. Most of the metal parts are titanium and hastelloy in the base. This is one molded unit. The balsa core adds some R value as well as stiffness, and it also is a great surface so that the powder doesn't stick to it. The manways, the little port that you see on the bottom part there so they can look in and see the activity, all these things were custom designed, and that unit that you see on top is the third one. The first one went to Louisville, Kentucky in a system. The second one went to Holland, and the third one last year, this unit, is back at the Louisville plant. for Lubisol. So this is a good example of our OEM work that we've been doing for years. The lower right-hand photo is one that we just shipped out probably a month ago. And that is a similar system, except it's a smaller system, and it's only about 36 inches wide. It vibrates. The whole system vibrates. So here again, we had to design it specifically so that everything could operate and vibrate. There's a few internals there that you can't see, but it's a good example of the kind of work that we can do. Here's another unusual corrosion project, the City of Detroit wastewater treatment. This is the largest single wastewater treatment plant in the nation. And the other large cities have multiple plants. Detroit has one very large plant. And what you're looking at is a pipe containment tray. And it runs between 7 buildings. It's approximately 1,700 feet long, and in a straight line. And the challenge was to design a system that could contain one 8-inch scum pipe and 2 4-inch hot water pipes. And they had to be insulated. We have a fiberglass 36-inch wide trough for the most part. We have 316 stainless steel angles on the top edge, all fabricated here at Crawford. We have channels and angles crossing over every 4 foot. These support the covers. They're concrete encased, and then the covers are all fiberglass, and they're all end-to-end matched. This system the design was started with the engineering firm in Detroit in 2009, and the bidding process came up in 2013, and we built it all through this past year. Air Design, our rep in Detroit, was involved with it, and it's an example of a very large custom project at a wastewater plant that we completed. Now, Ian would like to tell you about our expo coming up.
Okay, thanks, Terry. Just a few items to close with today. Coming up in January 26th to the 28th, Minoxidant will be featuring our source capture and our fiberglass products at the AHR Expo in Chicago. So we've got a booth set aside there, and we encourage everyone to stop by and visit us at that booth. And then also we'll be hosting a hospitality night on Monday the 26th at Harry Carey's restaurant. And for more information or to RSVP, please contact Paula in our office. Her information is listed there. So hopefully we'll have a good turnout and a good expo next month in Chicago. Also, just yesterday we launched the fiberglass-duct.com website in its new design. The new design is responsive for easier viewing on smartphones, tablets, PCs, and televisions. We expanded the case study area on this new version, and also the photo galleries. There's a lot of really good resources in there as far as code compliance, specifications, cut sheets. It's a pretty in-depth website and a lot of hard work by our fiberglass division as far as getting all that content in there. And then the mobile compatibility we think is a plus, with 40% of all users on the internet today using smartphones. That gives folks a tool to show photos and download specifications in the field remotely. So we're excited about that, and we'll be updating the Minoxidant source capture website here shortly as well. The webinars too are available online. We have a link on the FRP website we just looked at, and also the Minoxidant website. And we host all that on our YouTube channels, so you can always reference those down the line. We have a dozen at least webinars completed so far, so there's a lot of good information there, and we encourage people to check those out. We realize all of you are very busy, and we appreciate your time, so thank you for making time for us today. And as always, you see our contact information down there. Feel free to get a hold of any one of us for support on upcoming projects. And that's it for today. So happy holidays to everyone, and thanks again for your time, and we look forward to seeing you next month at our next webinar.